So let's talk about severe weather here, guys. I hate to, given everything else that's going on, but um, so this is an AM nest, right? Um, let's switch to HRR, triple R here, real quickly. So you have your cold air, and then we're starting off. Let's see, what time is this? Let's go 10Z. So this goes 18 hours out. You see dew point temperatures already pushing in the 60s, 50s, 40s, all the way up into northern Alabama here, according to this model, right? I think it estimates the current temperatures pretty well here in the south. Winds become more southerly, southeasterly, and you have what looks like a couple different surface lows along the cold front, some just low pressure areas. I'm not sure what's going on here, but you see that? So you see the warmest temps pushing up into middle Georgia here, okay? And along is generally where the coldest air, the cold front's back here, it's lagging a little bit, but the warmest temps pushing up into middle Georgia, right? And kind of getting cut off here as you go further in time, right? So I can't take a sounding from this, but you can only make out some flow veering, like coming from this way with looks like just a little, I don't know. Anyway, you see the low level winds, and then you have the winds to the south here, um, and then you have winds to the west here. So we could have a little disturbance moving along the line here, right? So what does that look like as far as the radar goes? So this is generally, and this is initialized 10Z. This is valid 20Z Sunday, January 25th. With Eastern time, that's 8 p.m. So that's around 4 p.m., right? A line of pretty strong storms moving through central Georgia, southwest Georgia into southern Florida. You see the little helicity swaths here on the line and how intense these line segments are. And that continues and it moves through central Georgia, southwest Georgia, and parts of the Florida Peninsula. You see these updraft helicity swaths in the circle areas, potential, circulations embedded within the line here. That continues as we go through time, right? Pretty intense line, even up into North Georgia here, and South Carolina and things like that. So, and then the line just kind of falls apart as it loses its support at the low levels here. So, going back, 19Z, which is 7 p.m., 8 p.m., 9 p.m., Zulu. So we're talking 3, 4, 5, 6. So this is one model depiction of it. We switch to the NAM Nest. So it's a little bit more delayed with this, and it has a kind of a more broken line of convection here moving through, but still could be intense. All right, so yeah, so I mean, when you compare this and HRR, I like to rely on for the short term, right? So pretty intense line segments here of trafficity. Even it looks like we have some. Let me take a sounding for Middle Georgia here. Wish I could for the HRR. Maybe I'll do that on a different model, but anyway, that's part of the analysis here, right? And so depending how far north the warm temps get, and right along where a warm front could potentially set up, which is right in this area, is where I think we get the highest salinity values. So we're gonna have to see where the warm front sits up as well. So one of the things we look at with severe weather is three cape, right? And this gives a good idea of the energy in the lowest levels. And you see the three cape here, especially into southwest Georgia and northern Florida, is in the hundreds, and even values in the 50s and 60s are indicative of a pretty unstable environment at low levels, right? So that's very important to look at here with this. So there's a sharp cutoff here, but wherever that sets up, in this model depicting that it's going to go pretty far north into central Georgia, the threat for severe weather exists here. Supercells are not out of the question here, especially further to the south uh, as we get into the deeper moisture, right, and the warmer temps. But anywhere in this green and yellow area, and maybe this red area here as well, is where you could have some potential embedded line segments or supercell develop here. I don't think it'll be going to be widespread, but the potential does exist here. I hate to say this too, but the potential for significant tornadoes exists. Unfortunately, we moved through time with this all the way parts of Alabama and into Georgia, right? And for central Georgia, right on the north end of this, but there's going to be a sharp cutoff here. But you can see anywhere in the green and yellow here is a potential for significant tornadoes. It's not high, but potential does exist here. Another thing you can look at with this is updraft helicity swaths as this system moves through, and you can see where they are. So updraft helicity is an important indicator for updrafts and where you can put that potential rotations in the line here. So the potential exists here, especially in the green here, where um, the updraft helicity gets pretty high. So not extensive by any means, but it's there nonetheless, and it's something to watch out for. I know I've talked this to death, but I wanted to review it in as much detail as possible here. So this is a 3 kilometer storm relative helicity plot, right, along with CAPE, right? So the CAPE meaning the convective available potential energy here, right? Not a lot of CAPE to work with here, but enough in this environment to get rotating updrafts. You see helicity values here are incredible. 400 meters squared per second squared, which is in the moderate to high threat range in the red here. So it's less down here. The vorticity is the highest right in central Georgia here along this boundary. So, and that's probably where the warm front is, right? I'm not sure if this is 3 cape or not, but let's switch to the mean layer cape values. Yeah, so this is, it's not, it's 3 cape, I think. So, wherever this cape sets up at the surface where we get instability, enough surface-based cape, we could have rotating updrafts, okay? Yeah, also the parameters are 0 to 1 kilometer helicity are off the charts here. And then northern part of this area, parts of central Georgia. It's just incredible here. Running like 440, 450 meters squared per second squared. And your cape 3 Cape. It's pretty high as well, high enough. You have 3 Cape at 50 joules per kilogram. You have the potential for severe storms here. You see it increases even more here. Let's bring this up with the helicity values. So we're really going to have to keep an eye on this, guys. There's a lot of data here. I sifted through it. Now I want to go to a sounding here. This is the NAM. It doesn't really, I'm just going to take a sounding from this area here. See what it looks like. And it's going to bring up a winter sounding. It takes a minute to process this sometimes. I'm sure this site is being used pretty heavily here. So generate new sounding with a severe profile. You see the hodograph. Pretty impressive here. Low level shear. Pretty incredible. You have temperatures warm enough. You have some corruption here in the rainfall, but you see the helicity here, 290 0 to 3 kilometer helicity, 300 meters squared per second squared. Cape, not high, but still high enough. And, like I said, we get some surface-based convection going on. We could get some tornadoes here, although the threat is higher for high winds. So I'm just wanting to give you an idea about this. Not a lot of instability in atmosphere, but for this time of year, it might be enough to get us some severe weather, unfortunately. So lastly, this is the surface wind gust as modeled by the HRR. I wouldn't take this to the bank, where you have updrafts and tornadoes. Obviously, you're going to have higher winds, but as this system moves through, you have the potential for high winds with any thunderstorms that move through here, right? So with a lot of energy in the atmosphere, we got to keep that in mind today as well.